In geometry, a hexagon is a polygon with 6 edges and 6 vertices. A regular hexagon has Schläfli symbol 6. The total of the internal angles of any hexagon is 720 a degree. Hexagonal structures, from B's honeycombs to the Giant's Causeway, hexagonal patterns are prevalent in nature due to their efficiency. In a hexagonal grid, each line is as short as it can possibly be if a large area is to be filled with the fewest number of hexagons. This means that honeycombs require less wax to construct and gain lots of strength under compression. Regular hexagon. A regular hexagon has all sides of the same length, and all internal angles are 120 degrees. A regular hexagon has 6 rotational symmetries and 6 reflection symmetries, making up the dihedral group D6. The longest diagonals of a regular hexagon, connecting diametrically opposite vertices, are twice the length of one side. From this it can be seen that a triangle with a vertex at the center of the regular hexagon and sharing one side with the hexagon is equilateral, and that the regular hexagon can be partitioned into 6 equilateral triangles. Like squares and equilateral triangles, regular hexagons fit together without any gaps to tile the plane, and so are useful for constructing tessellations. The cells of a beehive honeycomb are hexagonal for this reason and because the shape makes efficient use of space and building materials. The Voronoi diagram of a regular triangular lattice is the honeycomb tessellation of hexagons. It is not usually considered a tambus, although it is equilateral. The area of a regular hexagon of side length t is given by. An alternative formula for area is A equals 1.5 dt, where the length d is the distance between the parallel sides, or the height of the hexagon when it sits on one side as base, or the diameter of the inscribed circle. Another alternative formula for the area, if only the flat-to-flat distance, d, is known, is given by. The area can also be found by the formulas and, where A is the apothem and P is the perimeter. The perimeter of a regular hexagon of side length t is 6t, its maximal diameter 2t, and its minimal diameter. If a regular hexagon has successive vertices A, B, C, D, E, F, and if P is any point on the circumscribing circle between B and C, then PE plus PF equals PA plus PB plus PC plus PD. Tessellations by hexagons. In addition to the regular hexagon, which determines a unique tessellation of the plane, any irregular hexagon which satisfies the Conway criterion will tile the plane. Cyclic hexagon. A cyclic hexagon is any hexagon inscribed in a circle. If the successive sides of the cyclic hexagon are A, B, C, D, E, F, then the 3 main diagonals intersect in a single point if and only if A equals BDF. Hexagon inscribed in a conic section. Pascal's theorem states that if an arbitrary hexagon is inscribed in any conic section, and pairs of opposite sides are extended until they meet, the 3 intersection points will lie on a straight line, the Pascal line of that configuration. The Lemoine hexagon is a cyclic hexagon with vertices given by the 6 intersections of the edges of a triangle and the 3 lines that are parallel to the edges that pass through its median point. Hexagon tangential to a conic section. Let AB be a hexagon formed by 6 tangent lines of a conic section. Then Bryancon's theorem states that the 3 main diagonals AD, BE, and CF intersect at a single point. In a hexagon that is tangential to a circle and that has consecutive sides A, B, C, D, E, and F. Related figures, Petrie polygons. The regular hexagon is the Petrie polygon for these regular and uniform polytopes, shown in these skew-orthogonal projections, polyhedra with hexagons. There is no Platonic solid made of only regular hexagons, because the hexagons tessellate, not allowing the result to fold up. The Archimedean solids with some hexagonal faces are the truncated tetrahedron, truncated octahedron, truncated icosahedron, truncated cuboctahedron and the truncated icosiododecahedron. These hexagons can be considered truncated triangles, with coxeted diagrams of the form and. There are other symmetry polyhedra with stretched or flattened hexagons, like these Goldberg polyhedron G, 2, 0. There are also 9 Johnson solids with regular hexagons, regular and uniform tilings with hexagons, natural and human-made. See also, 24-cell, a four-dimensional figure which, like the hexagon, has autoplex facets and is self-dual, hexagonal crystal system, hexagonal number, hexagonal tiling, a regular tiling of hexagons in a plane, hexagram, six-sided star within a regular hexagon, unicasal hexagram, single path, six-sided star, within a hexagon. References. External links, Weierstein, Eric W., Hexagon, MathWorld. Definition and properties of a hexagon with interactive animation and construction with compass and straight. Cymatics are hexagonal shapes occurring within water sound images, Cassini images bizarre hexagon on Saturn, Saturn's strange hexagon, a hexagonal feature around Saturn's north pole, bizarre hexagon spotted on Saturn from space.com, suprahexagonal map for analyzing high-dimensional omics data.